Alright everyone, welcome to Systems of Inequalities. This is example B for 6.5. And here it says, Anna throws a ball straight up next to a building. The ball's height after t seconds is given by negative 16t squared plus 51t plus 3. Tom rides in a glass elevator down the outside of the same building. His height from the time Anna throws the ball can be expressed as 43 minus 5t. As Tom is riding down, he sees a bird fly above the elevator but below the ball. When did Tom see the bird? Give a range of possible times. Alright, before we actually go through and I would say graph, this is probably going to be the easiest method, is I would look at each one of these things. So what does this mean? Well, the negative 16t, that is for gravity. The negative 16t squared, negative 16 is gravity. 51t is initial velocity of the ball. It means she threw the ball at 51 feet per second. And then 3 is the initial height. Excuse me. Alright, so there's that equation, and then Tom starts at 43 feet up and then goes down at 5 feet per second. So that's the elevator speed going down. Alright, so what I did was I ended up graphing this right on my graphing calculator. So negative 16x squared, I used x instead of t because it only recognizes x as a variable, plus 51x plus 3, and that is the red parabola right there. And then the 43 minus 5x is going to be this blue one right here. So what we want to find out is we want to have it be above the elevator but below the ball, right? That's what it said. Tom is riding down, he sees a bird fly above the elevator but below the ball. So we want to know it's above this blue but below this red. Alright, so what I want to do is the most important thing with systems of inequalities, just like systems of equations, is where these two intersect. It doesn't have to be just lines. These two intersect. Here's one spot, 138, and here's the other spot, 2.5, 30.5. Alright, ooh, and I just lost them all. So there's one, and here's one. So that means it's got to be above this blue line, but below the red one. So that means it's going to be anywhere in this little region here. Alright, so that means anytime after 1 second, but less than 2.5 seconds would be the time. So if we wanted to go through and put the times here, we would say 1, hey, come on now. Or is it not going to let me do this? Apparently not. So it's going to be between 1 second and 2.5 seconds. And the height would be between 38, goes up, it goes back down to 30.5. So it's got to be somewhere between 30.5. Actually, it could be as high as whatever this maximum height is, 43.641. That would be the maximum height. So the lowest it could be is 30.5. The maximum would be here, but let's just see what the question says. When did he see the bird? Give a range of possible times. It'd be anywhere in between 1 and 2.5 seconds. All right, there's example B. Use this. That way when we get to class, you will know exactly what to do for what we're doing in class. See you later.